Hi everyone, in this video I'm going to solve O-Levels Additional Mathematics Paper 1 in a session October-November 2024 Paper 1-2. So let's start with the first question. Question number 1, the curve y equals to a cos bx plus c where a, b and c are integers passes through the point this and this. The curve has a period of 2 pi by 3. Part A, find the values of A, B, C. Okay, it is a cosine and the period, we know that the period of cosine function is 2 pi in terms of radians, right? Okay, now what is the formula for B? The B value is 2 pi over the given period, because cosine period is 2 pi and dividing by the given period. 2 pi over the given period is 2 pi by 3. So this is 2 pi times 3 over 2 pi, the reciprocal of the denominator. So now we can cancel the 2 pi and 2 pi. You will get the B value, which is equals to 3. So just plug the B value over here. So B equals to 3. This is the first solution. From here we have y equals to a cos 3x plus c. Now let's plug the points. The first point is minus pi by 6 and minus 2. Let me plug this point. Y is negative 2, a cos 3 and x value is minus pi by 6 plus c. Just simplify. Let me use a calculator. It is in radian mode. Okay, now we have cos 3 times minus pi by 6. It's 0. 3 times 1 is 3, 3 times 2 is 6. So cos minus pi by 2 is 0. Okay, this thing would be 0. So minus 2 equals to a into 0 plus c. So negative 2 would be equals to 0 plus c. So the c value is negative 2. We got the c value, which is an integer. Now, next step, we have to substitute this, the another point which is given to us. Let me do the rest of the part over here. Okay, let me plug the point which is pi by 9 and 1 by 2. Pi by 9 and 1 by 2. X and Y. Okay, so y equals to a cos 3x plus c value is negative 2. Okay, so y value is 1 by 2 equals to a cos 3 and the x value is pi by 9 and negative 2. 3 times 3 is 9. So this is 1 by 2 a cos pi by 3 and minus 2. Okay, let me simplify this. We have cos pi by 3 is 1 by 2. 1 by 2 equals plus 2. Shifting the 2 on the other side, it becomes a into 1 by 2. Alright, so what is 1 by 2 plus 2 is 5 by 2. This is equals to a into 1 by 2. So cancel the 2's. So a value is 5. You got the a as well, which is an integer. So we got all the three values of a, b and c, which are 5, negative 5, 3 and negative 2. Moving to part B, find the least value of y. Least value of y we have to find on the curve for 0 when x value is between 0 to pi by 2, the first quadrant, and state the values of x at which it occurs. At what least value we have to find that x as well. Okay, the function we have is y equals to a, which is 5, cos bx, b value is 3x and the c value is negative 2. This is the function. We have to find the least value of y. For the least value, or we can say the minimum value, what we have to do, we have to find the y prime and put it equals to 0 for the minimum value. Let me solve for the y prime, which is dy over dx. All right, 5 is constant. The derivative of cos is minus sine 3x, and the derivative of 3x is just 3, and negative 2 derivative is just 0. So we can say dy over dx, this would be equals to negative 5 times 3 is 15 sine 3x. We have to put this equals to 0 for minimum, for least value. All right, so let me plug this equals to 0 and solve for x. So dividing both sides by negative 15, this becomes sine 3x is equals to 0. So 3x would be equals to sine inverse of 0, or x would be equals to 1 by 3 sine inverse of 0, and the x value must lies between 0 and pi by 2, keep in mind. All right, it should be in radians. Yes, what is sine inverse of 0? Sine inverse of 0 is just 0, so that x value is equals to 0. Sorry, here we are just working with 3x. Yeah, 3x solution is 0, and there is another solution because sine of something is equal positive. So sine is also positive in the first and the second quadrant. For second quadrant, we use the operation pi minus that value. So pi minus 0 is just pi. All right, now we will get two solutions. X would be equals to 0 by 3, or x would be equals to pi by 3. So we have two solutions, x equals to 0 or x is equals to pi by 3. All right, so we have to find, and these two values lies in the given range between 0 and pi by 2. Right, now we have to work out the y value. So for y value, just plug into the equation when x is equals to 0. So y would be equals to, what is cos of 0? Cos 0 is 1. Okay, 5 cos 3 into 0 and minus 2. Y is equals to 5 into 1 minus 2. So here y is 3. And y is equals to 5 cos 3 into pi by 3 and minus 2. So 3 is cancelled with 3. What is cos pi? Cos of pi, sorry, negative 1. So y is equals to minus 5 minus 2, which is equals to minus 7. All right, we have to find the least value of y on this curve and state the value of x at which this occurs. So what is the least value of y? Which one? Y equals to 3 is the least value, or y equals to 7 is the least value? So we can say the least value of y is y equals to 7, not y equals to 3. So the least value of y is y equals to negative 7 at x is equals to pi by 3. When x is pi by 3, the least value is negative 7. Question number 2, it is given that y equals to f of x, where f of x equals to this. It is a polynomial function, a cubic polynomial. Part A, find the coordinates of the stationary points on the curve y equals to f of x. Coordinates of the stationary points. So keep in mind, for stationary point, you have to put the y prime equals to 0. Right? So what is y prime? Y prime is basically f prime of x. So this is df over dx, the function derivative with respect to x. All right, so let me take its derivative. It's a product rule, right? First function is as it is, the derivative of the second function. Second function, we use a power rule, power base function power minus 1 and the derivative d by dx of the base function, which is x minus 1. Plus the second function stays the same, the derivative of the first function d by dx of the first function 2x minus 5, which is just 2. All right, so simplify, this is 2x minus 5, and here we have 2 into x minus 1. 2 minus 1 power is just 1, and the derivative of x is 1 and this derivative is 0. So times it by 1 plus x minus 1 square, its derivative is 2. 2 into 2x minus 5 into x minus 1 plus 2 into x minus 1 square. Right, let me simplify this. So we have 2 into, let me take the product with 2x. 2x multiplying with this bracket, 2x square minus 2x. Now negative 5 is multiplying, minus 5x and plus 5. Plus 2 open, x minus 1 whole square. This is x square minus 2x plus 1. Now multiplying by 2. So 2 times 2. Okay, keep the 2 outside. 2x square minus 7x plus 5 plus 2 is outside, x square minus 2x plus 1. Now we can multiply by 2. 4x square, 2 times 7 is 14x, negative 2 times 5 is 10, plus 2x square minus 4x plus 2. So 4 and 2 would be 6, x square, 14 and 4, 14, 15, 16, 17, 18. So negative 18, x and plus 12. Right, that is the first derivative. We have to put this equals to 0 and solve for x and y. Further steps I'm going to do over here. So for stationary points, we have to find the coordinates of the stationary points, the x and the y, both coordinates, right? For stationary point, we have to put f prime of x equals to 0. 6x square minus 18x plus 12. This is the f prime of x. Okay, 6 is common. X square minus 6 times 3 is 18 and 6 times 2 is 12 equals to 0. We can divide both sides by 6. Right, 0 by 6 is just 0. So x square minus 3x plus 2, this is equals to 0, right? Now let me factorize this. So 1 times 2 is 2, minus 1 minus 2 would be 3. X square minus x minus 2x plus 2. These are the factors. X is common, x minus 1 is left, negative 2 is common, x minus 1 is left equals to 0. The two factors are x minus 1 and x minus 2. This is equals to 0. Putting both factors separately equals to 0. X minus 2 is also equals to 0. So from here x value is 1 and here x value is 2. So these are the x coordinates of the stationary points. So for the y coordinates of the stationary points, we have to plug the x values into the function. We have the function y equals to 2x minus 5 into x minus 1 square, which is given in the question. This is my y, right? Okay, plug the points one by one. When x is equals to 1, what is the y value? Y would be equals to 2 minus 5 into 1 minus 1 square. So 1 minus 1 is just 0. So this would be negative 3 and this would be 0. So we have 0. Y value is 0. Right? The next is when x is 2, solving for y, we have 2 into 2 minus 5, 2 minus 1 square. 2 times 2 is 4 minus 5 and 2 minus 1 square. 4 minus 5 is just negative 1 and this is 1 square. So the answer is negative 1 into 1 is just negative 1. So y value is negative 1. So we can say the coordinates of stationary points are x coordinate is 1 and the y is 0. And x coordinate is 2 and the y is negative 1. So these are the coordinates of the stationary points, right? Okay, now for the second part B, on the axis, sketch the graph of y equals to f of x, stating the intercepts with the axis. So as you can see, this is a polynomial function and it is a cubic function as well. Cubic polynomial function. Okay, and we have to state the x-intercepts and the y-intercept for this. Okay, so for the cubic function, the graph extends from first to third or second to fourth quadrant. All right, first to third or second to fourth, depend on the leading coefficient. As you can see here, the leading coefficient is positive for this function, right? It's not negative. So when the leading coefficient is positive, it extends from first to third or third to first quadrant, right? Let me write down the function. f of x is equals to 2x minus 5 and x minus 1 cube, right? So it's a cubic polynomial. The graph extends from first to third or second to fourth quadrant. Leading coefficient is positive. So when the leading coefficient is positive, the graph extends from first to third or third to first quadrant, right? Let me write down the zeros, or we can say the x-intercepts for this graph. For x-intercept, we have to put the function y would be equals to 0, or f of x is equals to 0, right? So what are the x-intercept? The first x-intercept is 2x minus 5. This is equals to 0. So x value is 5 by 2. What is 5 by 2 in terms of decimal? It's 2.5. Yes, this is 2.5. Okay, this is a 0 of order 1, right? Because its power is just 1. 0, this is order 1, right? This next is x minus 1 equals to 0, so x is equals to 1. This is a 0 of order 2 because its power is 2, right? Okay, now the x-intercepts. Let me label the intercepts. Let's say this is 1, this is 2, this is 3, and this is 2.5. We have x is equals to 1 and we have x is equals to 2.5. This is the 0, this is a 0, this is a 0 of order 2, so it makes a parabola over here, and this is a 0 of order 1, just a linear 0. Now find out the y-intercept as well. Okay, for y-intercept we have to put the function x is equals to 0. Okay, so y would be equals to 0 minus 5 and 0 minus 1 square. This is negative 5 and 1. So minus 5 is the y-intercept. It's downward, negative 5. Let me check. Minus 1, minus 2, minus 3, minus 4, and minus 5 over here. This is negative 5. The y-intercept, x-intercept, and x-intercept. And it extends from first to third or third to first quadrant. It depends on the leading coefficient because it is positive. All right, so it should be a parabola, this type of 0, and it passes through the y-intercept as well. All right, this would be the shape of the curve. This 0 is of order 1 and this 0 is of order 2, so it should be look like a parabola, and it also passes through the y-intercept. This is my y-intercept, and it moves to this quadrant as well. Okay, that's the sketch. Part C, hence find the values of k for which f of x equals to k has exactly one solution. When it has exactly one solution, we have to find the values of k when it has one solution. Okay, so when you see f of x equals to k means y equals to k, basically. When y value is 0, it has two solutions. It cuts the curve at 2 points. At this point is also two solutions. It has one, these are two solutions. Now here we have just one solution, all these k values. And at the top as well, it has one solution, right? So when k is more than, when y value is more than 0, it has one solution. We can say y is greater than 0. At y equals to 0, it has two solutions, but when y is greater than 0, it has just one solution. When we draw the line y equals to 0, it cuts the curve at 2 points, so it has two solutions. But at more than 0, it has just one solution, right? Let me check for the denominator as well. Okay, so for this, with the help of the first part, the stationary points. Stationary points are basically the turning points. What are the turning points? We got the coordinates of the turning points or the stationary points in part 1, which is 1, 0 and 2 minus 1. Sorry, it's just 2. These are the turning points. We got the coordinates of the stationary points, right? 1 and 0. X is 1, y value 0. We have done this. The other turning point over here is x is 2 and the y is negative 1. This is the turning point. When y equals to negative 1, we have again this and this. It cuts the at 2 points. This has one solution. But when the y value is less than -1, -2, -3, -4. So we have only one solution when y value is less than -1. I hope you understand the situation. So we can say the values of k are, when the curve has only one solution, is k is greater than 0 and k should be less than -1. So these are the two solutions. Question number 3. In this question, all length are in centimeters and all angles are in radians. Keep in mind. The diagram shows a circle with center O. So this is a circle. Sorry, this is a circle and its center is O. And radius is 12. So O to A and O to B, this is 12 centimeter. And a circle with center C and a radius of 5. C to A and C to B is 5. The circles intersect at points A and B. Okay, so the two circles intersect at the points A and B such that OA and OB are tangents to the circle. OA and OB, these two lines are tangent to the circle with center C. These are tangents to the circle with center C. And we know that tangent is always perpendicular to the radius. So OA is the radius, OB is the radius. So this is the tangent. So this is perpendicular and this is perpendicular. Right. Now for part A, show that obtuse angle ACB. We have A, C and B. This obtuse angle, whole angle, is 2.35 radians correct to 2 decimal place. We have to show this. For this, let's visualize the triangle O, B and C. Let me draw this. Okay, we have O, B is the right angle and C. This is 5 and this length is 12 we have given. We have to find this angle. You can see. And the other one is also the same 12 and 5 and the other angle. So times it by 2. It is a right angle triangle. We can use primary trigonometric ratios. So angle opposite is given and adjacent is given. So we use the ratio for tangent because we can say tan of theta is opposite over adjacent. So opposite is 12 and the adjacent is 5. So theta would be equals to tangent inverse of 12 by 5. Let me solve for theta. So it should be in radians. Tangent inverse 12 by 5 is 1.76. Okay. Theta is 1.176005. All right. Radians. So this other one is also same. So we can say obtuse angle ACB is 2 times of this angle 1.17600. Right, so times it by 2. So this answer is 2.3520. So we have to find up to 3 decimal place, 2 decimal place, 1 and 2. Up to 2 decimal place it is rounded to 2.35 radians. So it is true. Moving to part B, find the parameter of the shaded region. Parameter of the shaded region, we have to find out. This 12, this 12 and this as well. Okay, so the parameter is this length as well. So this is basically the arc length of this sector, this smaller sector, A, C and B. We have this angle. The arc length is radius times theta. Radius is 5 and we have theta. We already got the theta. So we can say arc length ACB is radius times theta. Radius is 5 and the theta is 2.35. We just got the 5 times 2.35. This is 11.75. Okay, so that arc length is 11.75 plus 12 plus 12. That would be the parameter. So we can say the parameter of shaded region is 12 plus 11.75. Okay, plus 12, this would be 35.75, or we round it to 35.8 centimeter is the parameter. Now for part C, find the area of the shaded region. Area of this shaded region. All right. So the shaded area is basically, this is a triangle OAC, OBC. These are the two right angle triangles, right? So area of a right angle triangle is half base times height. This is the base and this is the height. So we have to find area of this triangle plus area of this triangle. You will get the whole one and then subtract this sector, area of this sector, right? You will get the shaded area. So let me write this down. So the shaded area is area of triangle AOC plus area of triangle BOC minus area of sector ACB of a circle. Okay, so area of a triangle is half base and height. Base is 5 and the height is 12, plus half base is 12 and the height is 5. Sorry, it's 12 and 5 in both cases, base and height. Okay, now area of a sector, so it is in radians, right? So the formula for area of a sector is half radius square theta. So half, what is the radius of that circle? 5 is the radius of a circle and theta is 2.35. Let me write the formula over here. Area of sector in terms of radian is half radius square theta. Radius is 5 and theta is 2.35. Let me simplify all of them. 2 times 6 is 12, 2 times 6 is 12, and 5 times 6 is 30, plus 5 times 6 is 30, and minus 25 times 2.35. 5 square is 25 and divided by 2. This is 29.375. Okay, so add 30 plus 30 minus answer. This is 30.625. 30.625 centimeter square. That is the shaded area, or up to 1 decimal place it is 30.6 centimeter square. Question number 4. The function f is such that f of x is this for x is greater than a, where a is as small as possible. Number A1, write down the value of a. So x should be greater than 3. That would be the domain, right? So what is the domain of the logarithmic function? When the term inside the log should be greater than a. So we can say 3x is greater than 2. X is greater than 2 by 3. So x is greater than a. So from here a value is 2 by 3. So for part B, write down the range of the function. Let me draw the logarithmic function, the graph of the logarithmic function. Just ln x. So ln x is basically, this is a shape of the logarithmic function, right? So it covers, what is the range? You can see the range, it covers from the positive y values and the negative y values. Over here we have y positive and downward we have y negative. So it covers all the y values, 0, positive and negative. So for this function, when the domain is x is greater than 2 by 3, 2 by 3 is basically 0.67. When x value is more than 0.67, what are the y values? This should be the range, the curve in this case. This is, let's say, 0.67. right? So these are the range. What is the range? You can see the range is all real numbers. So we can say the range of f is all real numbers. This is R. All right. Now for the third part, find f inverse of x stating its domain and range. Okay, f inverse of x, we have y equals to f of x 4 ln 3x minus 2. So x should be equals to 4 ln 3y minus 2. X by 4 equals to ln of 3y minus 2. Okay, so e to the power x by 2 equals to 3y minus 2. E to the power x by 2 plus 2 would be equals to 3y, or we can say y or f inverse of x dividing by 3. 1 by 3 into e to the power x by 2 plus 2. This is my f inverse of x. The domain and the range. Okay, the domain of f inverse and the range of f inverse is, okay, now the domain, this is a domain of f of x, and that becomes the range of f inverse. Okay, this is the domain of f of x, which is x is greater than 2 by 3. Now the range of f inverse is greater than 2 by 3. The domain of f is the range of f inverse, right? The range of f would be the domain of f inverse, which is x belongs to all real numbers. Now for part 4, on the axis sketch the graph of y equals to f of x and y equals to f inverse of x, stating the intercepts with the axis. All right, we have to state the intercepts as well. All right, so f of x is 4 ln 3x minus 2, and f inverse of x is 1 by 3 e to the power x by 2 plus 2. Okay, let me find the x-intercept of f of x. X-intercept of f of x. F of x equals to 0. 4 ln 3x minus 2 equals to 0. Ln of 3x minus 2 equals to 0. 3x minus 2 is e to the power 0 is just 1. So 3x is equals to 1 plus 2. So x should be equals to 3 by 3. So x is equals to 1. This is the x-intercept of f of x, right? Let me label the x-intercept. This is 1. 1 is the x-intercept of f inverse of x. This should be the shape of the curve, because ln function is this is the shape of the natural log. Okay, it extend like this and downward. It approaches to y axis but not equals to that. Okay, so for f inverse, if x equals to 1 is the x-intercept of f of x, then y equals to 1 is y-intercept of f inverse of x. Right, so y equals to 1 is the line. Let's say this is y equals to 1. This is a sketch of f of x. So f inverse of x, this would be the sketch of f inverse of x. Okay, so that is a sketch of f inverse of x. All right. So here we can easily see the domain and the range of f of x. So this is a curve of f of x. So the domain is more than all the x values which are more than 2 by 3, and the range is all real numbers. And for f inverse of x, the domain is all real numbers. You can see all real numbers are the domain, and the range is which is more than 2 by 3. Now for part B, given that g of x is this function for x is greater than 0, solve the equation g of x equals to 9. G and g of x is 2x plus 1 to the power 1 by 2 plus 4. This would be equals to 9. Now g of this x is replacing with this term. So it's a square root of 2 and the x value is this 2x plus 1 square root plus 4, right? And plus 1 plus 4 equals to 9, right? G of x, I just wrote the g of x first. This step is clear. In the next step, g of x, this is going to be my x. Now this x value is going to replace with this term, right? The square root of 2x plus 1, this is a whole square root 2 of this x, and plus 1 and plus 4 is outside. So this is my whole x. Here we have a bracket, sorry. All right. Or if I can rewrite, we have 2 and we have 2x plus 1, power is 1 by 2 plus 4, and we have plus 1. This is the x value, its power is 1 by 2 plus 4 equals to 9. All right, so we have 2 is outside, 2x plus 1, power is 1 by 2 plus 4, and we have plus 1 by 2. This is 9 minus 4, 5, 6, 7, 8, 9, just 5 is left. 2 into 2x plus 1, this is in the square root, okay, plus 4 plus 1 by 2, this is equals to 5. Further simplification, we have 2 into 2x plus 1 plus 5, 1 by 2, this is equals to 5. Sorry, I messed up. This 2 is multiplying with this term and 2 is multiplying with 4 as well. This 2 and 2 times 4 would be 8. 8 plus 1, this is 9. All right. So 2 square root of 2x plus 1 plus 9, the whole square root, this is equals to 5. Okay, let me squaring on both sides. Squaring on both sides. All right, square of this side and the square of this side, this and this square root is cancelled out, so we have 2 square root of 2x plus 1 plus 9 equals to 5 square is 25. So 2 into square root of 2x plus 1 equals to 25, take away 9. Okay, 25 minus 9 is 16. 2x plus 1, this is 16 divided by 2. 2 times, okay, 16 by 2 is 8. This is 8. Okay, again squaring on both sides. To get rid of square root. Square of this and the square of this and square root is cancelled out. We are left with 2x plus 1 and 8 times 8 is 64. So here 2x would be equals to 64, take away 1 which is 63, and x would be equals to 63 divided by 2. 63 by 2, x value is 31.5. Okay, so we have x is equals to 31.5. That is the solution of the equation. Question number 5, part A, show that the left hand side equals to the right hand side. Let me start from the left hand side, which is 1 plus cot is basically cos over sine. Cos square theta over sine square theta, whole divides cos square theta over sine square theta. From here we have sine square theta plus cos square theta divides sine square theta whole divides cos square theta over sine square theta. The same denominators are cancelled out, sine square and sine square. So cos square theta, sine square theta plus cos square theta divided by cos square theta. So this is the identity that sine plus cos and their square would be equals to 1 over cos square theta. This is 1 over cos theta, its whole square. 1 over cos is secant. So secant square theta, and this is my right hand side. It is proved. Right. Part B. Write down the derivative of tangent theta with respect to theta. The derivative of tangent theta is secant square theta d by d theta of tangent tan theta with respect to theta. The derivative of tan theta with respect to theta. So, right, secant square theta is the derivative, right? Now for part C, using part A, we have to use a part A and part B. Find the exact value of this integral. Okay. All right, let me use part A first. From 0 to pi by 3, we know that 1 plus cot square over cot square. This is secant square, right? Write down secant square theta minus sine theta d theta. And what is secant square is the derivative of tan, using part B now. So integral 0 to pi by 3, secant square value is d by d theta of tan theta minus sine theta d theta. All right, split the integral now. Integral 0 to pi by 3 d by d theta of tan theta d theta minus integral 0 to pi by 3 sine theta d theta. All right, now d theta and d theta is cancelled out. Derivative integral is cancelled out. We have just tan theta and the limits are from 0 to pi by 3 minus. The integration of sine is minus cos from 0 to pi by 3. Just plug the value. This is tan pi by 3 minus tan 0, the upper and the lower limits. This negative and this negative makes positive. Cos pi by 3 upper limit minus cos 0 the lower limit. Let's find out the exact value. This should be in radians. Okay, tan pi by 3 root 3. And what is tangent of 0 is just 0 plus cos pi by 3 1 by 2. And what is cos 0? This is 1. And 1 by 2 plus 1 is, 1 by 2 minus 1 is minus 1 by 2, and this is root 3. So the exact value of this integral is root 3 and minus 1 by 2. This is the exact value. Question number 6, part A. Find in descending powers of x the first 3 terms in the expansion of this. Simplify each term as far as possible. Descending powers of x, it means decreasing power of x. Let me open this binomial expansion. X to the power 10, the first term power is n, plus x to the power 9, okay, 10c1, x to the power 1 reduce, and the second term is 2 over x square, its power is just 1, plus we have to find first 3 terms only. All right, and we have 10c2, the first term power is again reduced, 10 9 it becomes 8, and the second term power is increased by 1, so it is 2, up to so on. We are just dealing with the 3 terms, right? So we can say the first 3 terms are x to the power 10 plus, what is 10c1? Simplify. 10c1 is 10. X to the power 9, 2 over x square plus 10c2 is 45. X to the power 8, 2 square is 4 and x square is x to the power 4. So here we have x to the power 10. 2 times 10 would be 20. And what is x? X to the power 2 power is cancelled out. From 9 take away 2 is just 7 power is left. Okay, what is 45 times by 4? 180. 180 x to the power 4. Because just 4 and 4 is cancelled out, just power 4 is left. So these are the first 3 terms and the descending power of the expansion. Now for part B, find the term independent of x. Means the constant term. The term which is independent of x, or the term having x to the power 0 in the expansion of this. So here we have to use the term formula of the binomial theorem, which is t r plus 1 equals to ncr. The first term, we can say the first term is a, its power is n minus r, and the second term, its power is just r, right? So what is tr plus 1? N is 8, c, we don't know r, n is 8, right? First term is 4x square and the second term is 1 over 2x square. The first term is 4x square, it's 8 minus r. The second term is 1 over 2 x square, its power is just r. We have no idea what is r, right? We have to solve for, let me simplify this further. R plus 1, 8 c r. Here 4, its power is 8 minus r, and x 2 to the power of 8 minus r times 1 to the power r over 2 to the power r and x to the power 2r. So just solve for x. Solve for x. Because we have to find the term which is independent of x. It means the x coefficient should be equals to 0. So these terms involving x, these are the constants, these are involving x. X to the power 2 times 8 is 16 minus 2r multiply 1 over x to the power 2r. Okay, simplify further. X to the power 16 minus 2r and minus 2r, shifting this to the numerator. So it becomes x to the power 16 minus 4r. So from here, term independent of x, independent of x, it means the x coefficient should be, x power should be equals to 0. 16 minus 4r should be equals to 0. Minus 4r is minus 16. Negative is cancelled with negative. 4 times 4 is 16. So r value is 4. So plug the r value over here. So it means tr plus 1, it means the fifth term we are working with. Okay, r is equals to 4. So t 4 plus 1 is 8c4, 4 to the power 8 minus 4, skip the x, times 1 to the power r value is 4, divides 2 to the power r value is 4. Now just skip the x, right? So t fifth term is a term which is independent of r, right? Simplify. 8c4 is 70. 4 to the power 4, 1 to the power 4 is 1 and 2 to the power 4 as well. Okay, 4 to the power 4 is 256. Okay, here we have 70. 256 times 1 over 2 to the power 4 is 16. Right. Okay, 70 times 256, 70 times 256 and divided by 16, 1120. T5. Okay, we can say term independent of x is 1120. Question number 7, it is given that y equals to this function for x is greater than 1 over square root of 3, right? We have given the function and the domain. When x is 1, y is increasing at a rate of h per unit per h units per second, all right? Find in terms of h the corresponding rate of change in x, giving your answer in exact form. So when x is 1, y is increasing at a rate means dy over per second, dy over dt. X is equals to 1, dy over dt, this is equals to h units. Because y and rate means the derivative and this is with respect to time, it's seconds, right? So let me find out the derivative dy over dx. What is dy by dx? It's a quotient rule. So denominator function first, the derivative of the numerator function ln 3x square minus 1 minus the numerator function and the derivative of the denominator function x plus 2 divides the denominator function square. Right? Further simplification, x plus 2 is as it is. Derivative of ln of x is 1 over 3x square plus 1 and the derivative is 2 times 3 would be 6x minus this term is as it is, its derivative is just 1, and in the denominator we have a square, x plus 2 whole square. Okay, let me simplify this further. We have 6x is multiplying with this term, so 6x square and 6 times 2 is 12x divides 3x square plus 1 minus ln of 3x square minus 1. It's a minus 1, sorry. Thank God I figure out my mistake so early. Alright, that is the derivative. Okay, so when x is equals to 1, what is my dy by dx? Just substitute x equals to 1. 6 plus 12 divides 3 minus 1 minus ln of 3 minus 1 divides 1 plus 2 whole square. Simplify. 6 plus 12 is 18. 18 divided by 2, this would be 9. This term is 9 minus ln 2 over 3 square is also 9. So dy over dx, this would be equals to 9 minus ln 2 over 9 and x is equals to 1. Okay, so we have to find the corresponding rate of change in x. It means we have to find dx over dt. What is dx over dt? We have to work on it, right? Applying the chain rule, dy over dx is equals to dy over dt times dt over dx. This is the chain rule. This is at x is equals to 1. We have done dy by dx. We have dy by dt. We have to find dt over dx. Right? Okay. So substitute 9 minus ln 2 over 9. And this is dy over dt is h times dt over dx. Okay. So let me solve for dt over dx by dividing by h over here. So 9 minus ln 2 over 9h is dt over dx, right? But we have to solve for dx over dt. So taking a reciprocal, so dx over dt, this would be equals to 9h over 9 minus ln 2. Question number 8. The tangent to the curve y equals to this at a point where x is equals to 2, right? So we have this curve. We have to find the equation of tangent of this curve at x is equals to 2, right? So first, equation of tangent at x is equals to 2. So the step is, when x is 2, what is my y? Y is equals to e to the power 2, 2 times 2 plus 5 to the power 1 by 2. E to the power 2, 2 times 2 is 4 plus 5 and its power is 1 by 2. 4 plus 5 is 9, e square, and 9 square root is 3. So this is 3e square. This is my y, right? And for tangent we need the point. We have x is 2 and the y is 3e square. This is my xy. And we need the derivative as well, gradient at x is equals to 2. Gradient is basically dy over dx. Applying the product rule over here. First function is as it is, derivative of second function, applying the power rule. Power, the base function, and power minus 1. 1 by 2 minus 1, and the derivative of base function is just 2. Plus second function is as it is. The derivative of the first function is e to the power x. This 2 into is cancelled out. So we can say dy over dx, it becomes e to the power x, and 1 by 2 minus 1 is negative 1 by 2. So we have to shift this into the denominator to make it positive. So this is a square root of 2x plus 5. And plus e to the power x square root of 2x plus 5. Okay. Now let me solve the derivative at x is equals to 2. We have dy over dx when x is 2, e to the power 2 over square root of 2 times 2 is 4 plus 5, which is 9, and square root of 9 is 3. E to the power 2 square root of 4 plus 5 is 9, and this is 3. So e square over 3 plus 3e square. This is my derivative. So 3 times 3 would be 9. 9 plus 1 is 10. This is 10 by 3e square. Write down the equation of tangent. Equation of tangent is y minus y naught equals to m into x minus x naught. Y minus y naught. Y naught is this. This is my x naught and y naught, which is 2 and 3e square. 3e square. Gradient is 10 over 3e square x minus 2. This is my equation of tangent, right? Let's read the rest of the question. The tangent to the curve at the point where x is 2. So this is the tangent to the curve at a point where x is 2. This tangent meets the x-axis at the point x. It meets x-axis at point x. When it meets x-axis, it means the y component should be equals to 0. So we have to find x. Okay. Coordinates of point x. Tangent meet x-axis at this point. So it meet x-axis, the y equals to 0. Solving for x, so minus 3 e to the e square, 10 over 3 e square, x minus 2. Okay, solving for x, so minus 3 e square times 3 over 10 e square is equals to x minus 2. E square is cancelled with e square. 3 times 3 is 9 minus 9 by 10, and shifting the 2 on the other side, this becomes x. Okay, minus 9 over 10 and plus 2 would be 11 by 10 is my x. 11 over 10. So we can say the x coordinates are 11 by 10 and 0. Okay, further, and y-axis at point y. The tangent meets the y-axis, means the x should be equals to 0, and find out the coordinates of y. Okay. The remaining steps over here for question number 8, we can say coordinates of point Y. This is x should be equals to 0 in equation of tangent. Let me check. This is the equation of tangent. Write down x equals to 0 and solving for y. All right. Okay, y minus 3e square equals to 10 over 3e square. X is 0 minus 2. Y would be equals to 10 over 3e square into negative 2, and shifting this term becomes 3e square. All right. So y is equals to 10 times 2 is 20 minus 20 by 3 e square and plus 3e square. Minus 20 by 3 and plus 3 is 11 by 3 with the negative sign, yes. So here y is minus 11 over 3e square. So the coordinates for the point y is the x is 0 and the y is minus 11 over 3e square. All right. Okay, read the further question. Find the coordinates of the midpoint of xy, giving your answer in exact form. We have to find the midpoint of xy. All right. Now we have x, which is 11 by 10 and 0. And we have y as well, which is 0 and minus 11e square over 3. We have x and y both. Find out the midpoints. Midpoint is adding the x components and dividing by 2. 11 by 10 plus 0. 11 by 10 plus 0 divided by 2. Adding the y components and divided by 2. This is 11 by 10 divided by 2. 11 by 10 divided by 2 is 11 by 20. Okay, and this is 11 by 3 divided by 2 is minus 11e square over 6. These are the exact coordinates of the midpoints of xy. Question number 9. The diagram shows the part of the curve y equals to, yes, the part of this curve and a straight line all right. Find the area of the shaded region. This shaded region, we have to find the area, giving your answer in the form of ln a plus b, where a is an integer and b is a rational number. A should be an integer, can be positive or negative, and b is a rational number in the form of p by q. All right. So for this, here x value is 0, right? We have to find the point of intersection of the curve and the line. This curve and this line. Find out their point of intersection. Let's do this. Here we have y. What is y over here? Y over here would be 6x by 2 plus 1 by 2, which is 3x plus 1 by 2. Right. So comparing both sides. This y is 3x plus 1 by 2. And the other y is 4 over 2x plus 1. 2 times 3 would be 6x plus 1 divided by 2 equals to 4 over 2x plus 1. So we have to find first point of intersection of line and curve. This is my first step, right? Cross multiplication we're gonna do. Yeah. Okay, so 6x plus 1 is multiplying with 2x plus 1 and 4 is multiplying by 2. 6 times 2 is 12x square plus 6x plus 2x plus 1 equals to 8. 12x square plus 8x plus 1 minus 8 equals to 0. 12x square plus 8x minus 7 equals to 0. Okay, let me factorize this. Okay, 12 times by 7 is 84. Factors of 84. or we can say, let's do a quadratic formula. X is equals to negative of b value plus minus square root b square minus 4 times the a value and the c value divides 2 times of a. Simplify. Minus 4 times 12 times minus 7 and add 8 square is 400. So here we have x is equals to minus 8 plus minus square root of answer 20 over 24, because 2 times 12 is 24. Okay, let me write down the two solutions over here. We have x is equals to minus 8 plus 20 over 24, or x is equals to minus 8 minus 20 over 24. Minus 8 plus 20 divided by 24, 1 by 2. Minus 8 minus 20 divided by 24 is minus 7 by 6. Okay. So here you can see the x is equals to 0. And what is this point? Here x should be positive, right? Not the negative one. So this value we are using, which is 1 by 2. So the area, the shaded area becomes, we have to find the area under this curve. This curve, and area under the curve between 0 to 1 by 2, and then subtract this area of a trapezium, because this is a shape of a trapezium. Or we can say we have to subtract the area under this line, right? So these are the x equals to 0 and the point of intersection is 1 by 2. So area under this curve is the integral of this curve between the 2 points. This is the area under the curve, but the shaded area does not include this portion. So area under the line we have to subtract between 0 to 1 by 2. We will get the shaded area. Let me write this down. We can say shaded area is equals to area under the curve. This is the curve, right? Area under the curve between 0 to 1 by 2, 4 over 2x plus 1 dx, minus area under the line between 0 to 1 by 2. The line is 3x and plus 1 by 2. This is the line, right, with respect to dx. Right, let me simplify. Okay, so 1 over x is ln of x when its derivative is completed. Its derivative is 2x, so we can split 4 as 2 times 2. 2 is outside, 0 to 1 by 2, 2 is inside. I just split 4 2 times 2, 2x plus 1 with respect to dx, minus integration of 3 and x derivative integration is x2 by 2, plus 1 by 2 integration is with x. The limits are between 0 and 1 by 2. Okay, this is 2. So when the derivative is complete into the numerator, so its integration is ln of 2x plus 1, 0 to 1 by 2, minus 3 by 2x square plus 1 by 2x, 0 to 1 by 2. Now let me apply the upper and the lower limits. So 2 ln of 2 times 1 by 2 plus 1 minus 2 ln of 2 into 0 plus 1. This is the first function, minus the second function. Upper limit is 3 by 2 1 by 2 square, minus the lower limit is just 0, because 3 by 2 times by 0 is 0, plus 1 by 2, x is 1 by 2 upper limit, and the lower limit is again 0. 2 ln of 2 minus 2 ln of 1 minus 3 by 2 into 1 by 4 plus 1 by 4. This is 2 ln 2 minus 2. What is ln 1? Ln of 1 is, I guess, 0. Yeah, ln 1 is 0, minus Okay, this is 3 times 1 is 3, 2 times 4 is 8, plus 1 by 4. This is 2 ln 2 minus 0, 3 by 8 and add 1 by 4, 5 by 8 minus 5 by 8. Or we can say, shifting the power, ln of 2, its power is 2 minus 5 by 8. So we can say the shaded area is ln 4 minus 5 by 8. 2 square is 4. Question number 10, part A. The first three terms in the arithmetic progression are first term, second term, and third term. Find the values of x. We have to find the values of x between minus 180 to plus 180, for which sum to 30 terms is this. Means when S30 is equals to 455 square root of 3, we have to solve for x. What is x? The values of x, not just one, it can be more than one values. Okay, so for arithmetic progression, what is the sum formula? Sn equals to n by 2 into 2a plus n minus 1 into d. Okay, so here n is 30, a is my first term, which is 2 tan x, and d is the common difference between the first and the second term. 5 tan x minus 2 tan x, second term minus the first term. This would be 3 tan x is my common difference. 3 tan 2x. Okay, now plug the values. N by 2, 30 by 2 into 2 times of a, 2 times of a, 2 times of 2 tan x plus 30 minus 1, and the d is 3 tan 2x. It's 2. God. Angle is always 2x. Keep in mind. This would be 455 root 3. Now we have to solve for the values of x. 2 times 15 is 30. 15 into 4 tan 2x plus 29 3 tan 2x equals to 455 root 3. Simplify this further. We have 15, 4 tan 2x plus 3 times 29. 3 times 29 is 87. 87 tan 2x, and 87 add up with 4 is 91. This is 455 and root 3. Alright, so 15 into 91 tan 2x is 455 and root 3. Okay, 91 times it by 15. This is 1365. 1365 tan 2x is 455 root 3. Okay, so tan 2x is equals to 455 root 3 divides 1365. 455 root, okay, 455 root 3 divided by 1365. Okay, or 455 divides 1365, 1 by 3 root 3. Okay, so we can say tan of 2x is root 3 over, we can write down 3 as root 3 into root 3. Root 3 square becomes 3. These are cancelled out, so it is just 1 over root 3. What I did over here, most of the students get confused. I wrote 3 as root 3 into root 3, because this is root 3, its whole square, and I will again get 3, right? So we can write down a number into the product of two roots, right? Tan 2x is 1 over root 3. We have to find the values of x, and the x values must lies between minus 180 to plus 180. Alright, so let me simplify now. Simplification is 2x would be equals to tangent inverse of 1 over square root of 3. It should be in degrees. Let me convert my calculator into degree mode. Yes. What is tangent inverse of 1 over square root of 3? It's 30 degree. Okay, let's say this is my theta. Theta is 30 degree. Now we have to check tangent is positive in which quadrant. Apply the cast rule. C, A, S and T. Here tangent is positive. Here only sine is positive. Here tangent is positive. And here cos is positive. So tangent is positive in the first quadrant and in the third quadrant. First quadrant we use the value of theta, and the third quadrant we use the value of 180 degree plus theta. So other value of theta is in 180 add 30 to 10. So these are the two solutions. But look at the angle. As you can see, angle has two revolutions, 2x, 2x, 2x. So we have to add and subtract 360, the complete revolution, right? So since we have the range between minus 180 to plus 180, so we have the positive value, so it is better to subtract only 360. Okay, so in all the theta values, theta minus 360 degree and theta minus 360 degree. So theta is 30. In 30 degree subtract 360 degree, and in 210 subtract 360 degree. Because of the two revolutions we are subtracting 360. We can add as well, but from addition we do not get any solution. 30 minus 360 is 330, and 210 minus 360 is minus 150. So these are the four solutions. Let me find the value of x back, because theta is basically 2x. So theta is equals to 2x, and its solutions are 30 degree, 210 degree, minus 330 degree, and minus 150 degree. So each time you have to divide it by 2 to get the value of theta. Okay, get the value of x. So what is x? My x is going to be, okay, 30 divided by 2. This is 15 degrees. This belongs to the domain. 210 divided by 2 is 105 degree. It also belongs to the domain. Okay, minus 330 divided by 2 is minus 165. It belongs to the domain. Minus 150 by 2 is minus 75 degree. It also belongs to the domain. So all, we can say all values of x lies between minus 180 degree is less than equals to x is less than equals to 180 degree. So these are the solutions. Now for part B, the first three terms of a geometric progression are first, second and third, and theta is between minus pi by 6 to 7 pi by 6. Find the values of theta for which this geometric progression has sum to infinity. The geometric progression sum to infinity, its formula is s infinity equals to a over 1 minus r, where a is the first term, r is the common ratio, and the r must lies between minus 1 is less than r is less than 1. R values lies between minus 1 and plus 1. So basically in this question we have given for which this geometric progression has sum to infinity. This geometric progression already has some sum to infinity. We have to just solve for the theta value. The sum to infinity exists for this geometric progression. So using this and find out the theta. Let me solve for r. R is the common ratio. Second term divided by the first term. So what is the second term? Second term is 20 cos to the power 4 theta minus pi by 2 divides the first term is 5 cos square and theta minus pi by 2. Okay, so 5 times 4 is 20 and this square is cancelled, just one square is left. So the common ratio is 4 cos square theta minus pi by 2. This is the common ratio. Just plug over here and solve for the value of theta. Minus 1 is less than r is less than 1. Minus 1 is less than 4 cos square theta minus pi by 2 is less than 1. Right. So the first step is you have to divide all the terms by 4 because we have to solve for theta. Minus 1 by 4 is less than cos square theta minus pi by 2 is less than 1 by 4. Alright. Okay, so for further simplification, we have to take the square roots to get rid of square. This square and square root is cancel out. Square root of negative 1 by 4. Here we will get the complex number. We are dealing with the real ones, not the complex one. This implies we can say cos of theta minus pi by 2. This should be less than plus minus 1 by 2. Because root of 1 is 1, root of 4 is 2. So here we have two cases. The first case is cos theta minus pi by 2. This is equals to 1 by 2. And the other case is cos theta minus pi by 2. This should be equals to minus 1 by 2. So keep in mind your calculator should be in radian this time, right? So let x is equals to theta minus pi by 2. This implies cos of x is equals to 1 by 2 and cos of x is equals to minus 1 by 2. Now here we have to use the cast rule as well. So if I can draw over here. Okay, so C, A, S and T. So here cos x is 1 by 2. Cos x is positive of something, right? So positive means cos is positive. In here you will get the first and the fourth quadrant. The solution must lies between the first and the fourth quadrant for this case, and second and third quadrant. Second and third quadrant. Your solution lies, right? Let me start doing this. This is the B part of 10, right? So cos of x is 1 by 2. X is cos inverse of 1 by 2. So what is x? My calculator is in radians. Cos inverse 1 by 2 pi by 3. Okay, we have the solution pi by 3. And also we know that cos is positive in the fourth quadrant. So this pi by 3 lies in the first quadrant. Now for the fourth quadrant, what is the operation? The operation for the fourth quadrant is 2 pi minus this x value. 2 pi minus pi by 3. 5 pi by 3. Let me check for the next one. When cos of x is minus 1 by 2. So x should be equals to cos inverse of 1 by 2, which is pi by 3. We already got. But now cos is negative in second and third quadrant. Now what are the two x values for the second and third quadrant? For second quadrant, we have the operation pi minus theta and the next is pi plus theta. So pi minus pi by 3 and pi plus pi by 3, right? So we have pi minus pi by 3, which is 2 pi by 3. And the other one is pi plus pi by 3, which is 4 pi by 3. All right. So these are the 4 solutions for, the values of x, not the thetas. Now put it back. As we know that, let's say x is equals to theta minus pi by 2. But we have to solve for theta. What is theta? Theta is equals to x plus pi by 2. In all these x values, we have to add pi by 2 to get the theta, right? So let me solve for thetas now. Pi by 3, add pi by 2. So pi by 3, I can take 1 by 3 plus 1 by 2 is 5 pi by 6. The other one, 5 pi by 3, add pi by 2. So 5 by 3, add 1 by 2. 13 pi by 3. Pi by 6, 13 pi by 6. Again, add 1 by 2. 2 by 3 plus 1 by 2 is 7 pi over 6. And the last is 4 by 3 and minus 1 by, add 1 by 2 is 11 pi over 6. All right. So these are the theta values, right? So as you can see in angle, we have theta minus pi by 2. So we have to subtract 2 pi in all these values, right? Okay, 2 pi minus all these theta values, or theta minus 2 pi. So theta minus 2 pi, in all these values we have to subtract 2 pi. So 5 by 6 we have to subtract 2. This is 7 by 6 pi with a negative. 11 by 13 over 6, 13 by 6 we subtract 2. 1 by 6 means pi by 6. 7 by 6 minus 2 is minus 5 by 6 pi. 11 by 6 minus 2 is minus pi by 6. So now these are all the values, 4 and 4, 8 values of theta. Now let's see the domain we have given. It must lies between minus pi by 6 and 7 pi by 6, those theta values. Okay, minus pi by 6, this belongs. Minus 7 pi by 6 is not included. Yes. Minus 5 pi by 6 not included. Pi by 6 is included in it. 5 pi by 6 is included. 13 is more. 11 is also more. 7 pi by 6 is included, right? So the solution, the theta values are between minus pi by 6 to 7 pi by 6, right? Keep in mind. The domain of this is minus pi by 6 is less than equals to theta is less than equals to 7 pi by 6. So the positive, this is the solution. 5 is also included. 13 is more. 7 is included. 11 is more. For negative, just this one is included. These are not inside. So we can say the solutions. We can say the values of theta are minus pi by 6, pi by 6, 5 pi by 6, and 7 pi by 6. Alright, so these are the values of theta. So that was the last question of our paper. If you have any queries, please let me know in the comment section, and please subscribe to my channel. Thank you for watching. See you next time. Take care.